I got it. I'm in control.
I know you're in control, but I just.
Hi, everybody. We are going to get started here shortly. If Uta and Gada could please raise their hands. Uta Hayden, could you raise your hand, please? And then just a reminder to our speakers to mute your video while you're not speaking. Thank you. Gada, do you hear us?
Yes, yes. Do you hear me?
Okay,
Yep.
yes, we do. Steve is going to be giving a few introductory remarks. We will start right at the top of the hour. Once again, a plea for Uta Hayden to raise your hand in the audience.
Mary Beth, I was preparing one slide to show at the beginning, maybe after Stephen has talked.
Sure. Yeah, Arnold, you'll have to stop sharing then.
Okay, so Uta, she just says she can't hear anything and she can't find a button to speak. Okay, super.
Just
sure what
so,
she does.
Yeah, I'm not sure where she is. Make sure she's in session 4 and not in the lobby.
Okay, I just sent her name. Are you in session?
Okay, she can see and hear us. All right. Please raise your hand.
Here, I can invite her to the stage.
Okay, she's already on the stage. Okay. All right. No, she's not. Yeah, go ahead and invite her on the stage, Steve. Gotta go ahead and share your screen.
Can you see my screen?
We can. Go ahead and go into presenter view. Yeah.
Okay, so this is so then the session has started already. I would like
Yes.
to. Okay,
Yes.
thank you.
But remember, Steve is gonna talk first, but your slide is not in presenter view. You may want to go into the presenter mode.
It is in the presenter mode.
Now click on view. Click on the view button. We're not seeing it in presenter mode.
Okay, so then I stop sharing. Okay, I share again.
Do we have Uta up on the stage yet?
I don't see her. Hendrik, I know you're out there. Can you help us elevate Uta Hayden to the stage?
It's very weird. Can you see it in the presenting mode?
We don't. But just go ahead and keep it that way.
Yeah. Oh.
All right.
So first Stephen, then myself.
Yeah, I'll just speak for a minute. I'm just going to try one more time. We could find her.
You still see my screen, right?
Yes.
Okay, I think I did it that time. Uta Hayden will not join the stage as microphone permission something.
All right. Uta, if you're out there, try rejoining the session. When it asks you to enable your microphone, choose yes, choose allow for both options, please. Actually, it would be best if you could go find your speaker invitation in your AirMeet and use that link. I think we need to go ahead and get started.
Yeah, okay. I mean, maybe could we have them go third?
Mm-hmm.
If so, I'll leave it up to you, Gada, to being moderator. At any rate, good morning, good afternoon, good evening, everybody. Welcome to the second day of the AquaWatch 2022 meetings. Thank you for taking time out of the day to attend. We're going to switch gears a little bit today and talk about the theme being the future of water quality science and technology. So we're going to look a little bit at some data frameworks, some of the technology, and some of the and hear from some of the space agencies. But we're also going to hear from some of the early career people and not just talk about the science and technology, but the people for our future. So it should be an exciting day. And to start us off, Gada is going to moderate this first session. So I'll turn it over to her.
So thank you. Maybe I can introduce myself. My name is Ghada Al-Serafi. I'm working at Deltaris in the Netherlands. My specialty is data science, and I'm a specialist in Deltaris. I just want to maybe put a little bit this session into context and highlight the things that has just been mentioned. So the session is about the new and emerging data types, but I would like to think with you on the service chain. So the service chain, which is actually what we are producing from the data towards the users, and this is really the session is going to be covering a couple of components here. So if we are talking about data from different sources of data and we are merging that and doing analysis and having frameworks that is going to be also discussed by Arnold Decker. So the framework of processing the data, analyzing it, we are also going to be looking at the data is not enough. So we have models, we have forecasting capability, but we are also merging the data in data fusion that would be also highlighted by Nicole Pinnell. And then we are doing all of that in an operational system to serve the users. So we are going to be highlighting that through user-friendly study cases presented at the end. We can also see that whatever we are doing in the service chain is to provide specific information with high accuracy to the users to enable them to solve their problems. So having said that, I would like to invite Arnold Decker to give the first speech. Arnold?
Yes, I need to be able to share my screen.
And please present yourself while sharing your screen.
Yes. Okay. Well, welcome everybody. I'm Arnold Decker. I currently work for my own company, SETDEC, but I'm affiliated with Commonwealth Scientific Industrial Research Organisation in Australia, with the University of Queensland and Australian National University. And I'm also a co-chair of GEO AquaWatch till the 1st of April. And then I'll stand down as co-chair. So, the GEO AquaWatch Aquatic Reflectance Analysis Ready Data Framework, what it means and why collaboration matters. Now, you may wonder why this talk is in the new and emerging data types. And I'll try to explain it to you, because initially that might not be the most logical place. I must also say that if we had a face-to-face meeting, we would have had probably 6 or 8 or 10 presentations, and we had to choose 3 for the session because it became a virtual conference. And I would like to specifically thank Daniela Gerlin, Steve Laban, and Christopher Barnes for all their collaboration. So the Aquatic Reflectance Product Family Statement, so PFS is Product Family Statement, had significant contributions from all these people. And you can see it's a very nice distribution of people across the world and different expertises and with different backgrounds in their institutes and many others that I haven't mentioned in Waterforce, GEO AquaWatch, etc. So what is analysis-ready data? But from CEOS, they've defined it as the systematic, radiometrically, atmospherically, geometrically, and spatially corrected full archive Earth observation data sets of normalized water-leaving radiance or reflectance. And that can lead to interpretation-ready data, which are the derived products. And they're derived from analysis-ready data through application of Earth observation algorithms. And this is really important. And this is also why it's important that the analysis-ready data, that we finally start developing global standards. And that's what this talk is about. So we have multiple players around the world who are developing analysis-ready data from the same Earth observation data sources. What we want to avoid is that the end users at a certain moment get products from different providers with very different results, because that would reduce the amount of trust in Earth observation data. And in the sessions yesterday, one of the most important aspects for Earth observation data was that for them to be taken up by the end user community is trust. Now, differences in, let's say, water quality variables from the same remote sensing data can be due to variations in analysis-ready data processing, as well as the algorithms, of course. But if we standardize the analysis-ready data with a proper framework, then we start excluding that possibly as a source of differences. And if you want to compare the effectiveness of algorithms, you must be sure that the analysis-ready data is similar. So analysis-ready data interoperability can pave the way for harmonized and fused data products. So this started as a CEOS activity led by the United States Geological Survey. But then GEO AquaWatch got involved because the USGS group that was involved had no experience in remote sensing of water quality. So GEO AquaWatch became involved. And why did we do this from GEO AquaWatch? Well, I explained already the different ARD approaches, easier to compare algorithms. But there's another aspect, which is that we also have to think about getting proper calibration validation water from some of these water bodies. And I just wanted to refer you to the GEO AquaWatch, sorry, it's the NASA GEO AquaWatch workshop, validation of satellite-derived optical and water quality parameters for coastal and inland waters in medicine in the United States. And I think you can submit an expression of interest to attend that till the 1st of April. So this is the CEOS analysis-ready data for land framework. We are in the land framework because inland waters occur in the land mass, but it also applies to near coastal waters, coral reefs, and seagrasses, etc. So I already gave you the card for L definition. Then from that, you go to the product family specifications, which are the actual documents, where we have threshold and target metadata fields. Threshold is the minimum requirement. Target is the desired requirement. And there are 4 big groups, which is general metadata, per pixel metadata, radiometric and atmospheric corrections, and geometric corrections. Then the next stage is, once that has been established, the PFS, then people who provide ARD data, or groups or institutes, can do a self-assessment. The self-assessment can then be peer-reviewed in collaboration with the CEOS team, And then you can get a Card for L compliant stamp if you want that. None of this is compulsory. This is all voluntarily, by the way. So here we have some definitions. I don't want to read out these slides. You can read them yourself. What is interesting to see is that there are multiple product family specifications now, of which 5 have been endorsed. And aquatic reflectance is the most recent to be endorsed. And there are still 4 in progress, such as nighttime light surface radiance, interferometric radar, LiDAR, etc. And again, I explained to you the self-assessment process, which providers of ARD data can now do. And this is the website of CEOS. So if you just type in ceos.org/ARD, you get to this website. And here you can see that at the bottom is aquatic reflectance, very fresh. It was fully approved on the 3rd of March, version 1. And you can download the PDF and the Word file as well. So this is very, very recent development. So this was coordinated by Andres Sekira from Geoscience Australia and Chris Barnes. We started actually a bit earlier, but formally we started in March 2020. And then we had some intense meetings to try and get this all sorted out. It applies to all multi and hyperspectral sensors, measuring in the wavelength bands relevant for water quality. We use the surface reflectance for terrestrial remote sensing as a baseline, but then we started tweaking that to be more appropriate for water quality. And we had a large group of people involved. And I'd specifically like to thank Daniela Gerlin for keeping me on the straight and narrow and making sure that we were very thorough in what we did. So on the right-hand side, you see the actual documents if you would go to the website where you can download it. And here is the requirements of the summary of changes that was necessary to go from terrestrial surface reflectance product family statement to the aquatic reflectance one. The general metadata we could keep the same, but the per pixel metadata, we had to modify 2 requirements. For instance, lake and river ice was an important issue, which we don't have in Australia, but you do have in the Northern Hemisphere. And 10 new requirements were identified that are unique to Earth observation over water quality. You can read them here. There's some that you may not have thought of, such as being able to discriminate optically deep or optically shallow waters, sky glint, sun glint, etc. But I just want to highlight the adjacency effect, atmospheric adjacency effects requirements, because that's where we actually run into trouble. And we had some very, very big discussions, but it was also great to understand how this system actually works. So this is the actual field for adjacency effect correction. And in the end, we came at the bottom, you see that the threshold requirement is not required. Many experts, which including myself and others, said, well, we do want a threshold requirement for adjacency effect because it is very important to correct for it. So we actually wanted a comment there which said, please do atmospheric adjacency effect correction as best as you can and report back on it. But then the USGS, as a very experienced agency, said, we can't do that because if we do a self-assessment and there's a comment there, well, do the best you can, if you can, that's a gray area. You can't say, yes, I've met the target, or no, I've not met the target. So in the end, we had to compromise and say, okay, we can't have a threshold requirement if it's not clear how you do a self-assessment against it. This also means that it's very clear where innovation is needed, or R&D investment, which is to get that target, desired requirement, into the threshold requirement, because then it's stable and operational. So that's why this talk in the end does lead to new and emerging data types and to innovation. So this is a summary of those changes. You can go and download the document from the website. I'll give you the links right at the end of my talk. So this is the current status. 3rd of March, it was actually fully endorsed. The USGS actually did an informal self-assessment evaluation, and they only found that there were only 2 fields that they currently don't meet. But it also gave them, of course, then pointers towards which area they have to focus on to meet all the requirements. And really important is the last sentence. This is a living document. It can be changed every year if we want to. If we feel as a community that we've progressed, so something from target can go to threshold, or if there's a threshold field like adjacency effect that is not yet filled in, we can start filling it in. So every year this can be reviewed, and obviously if we see how fast our field is evolving, this will need doing once every 1 or 2 years. So going towards global water quality monitoring and assessment, our whole area is maturing fast. Do we have fully operational products everywhere around the world? No, we do not. We're on our way, but we're not there yet. But we do believe establishing this CEOS analysis ready data for land aquatic reflectance framework is a relevant step to operationalize Earth observation information, compare providers with the ARD outputs, increase the professionalism of providers and therefore trust by end users. And it identifies areas of R&D investment by academia, science institutes, space agencies, companies, etc. for operationalization. Because specifically, if the threshold entry is empty, the target has a field, metadata field, that means it's still in research mode. So how do you go from research mode to make a threshold, which is operational mode? You can also have fields with, there's a threshold, which is a lower level requirement, target is a higher level requirement. Okay, how do we get that higher level requirement from target to threshold level, etc.? So that's where the innovation lies. And this is also probably important to start telling our funding agencies that these are the priorities to fund. Collaboration. Now, this was a massive collaboration. We needed an experienced agency like the USGS to help us, explain to us how this works. But we also needed a domain expertise in inland and near coastal waters, and that we got from GEO AquaWatch, from Waterforce, from Prime Water, from CEOS, etc. And we had to compromise. Not everybody got their desired outcome, and that's logical in a case like this. These are the web links. The top one is probably the easiest, ceos.org/ARD, but we have the other web links, which are a bit more detailed. You can also go to GEO AquaWatch resources. And that's the end of my presentation. Raise awareness if you can, also to funding agencies, propose improvements, be part of our cycles of review, and thank you very much for your attention.
Thank you, Arnold, for this inspiring presentation. I think we are going to be having there are no questions in the chat, so maybe at the end we can have also other questions. So please, I invite everyone, if you have questions for Arnold or other speakers, please write it in the chat. So I would like, thank you, Arnold, again. I would like to invite the second speaker, and please present yourself.
Okay, hello. I'm sharing my screen.
Hello, everyone, also from my side. Thanks for letting me in or helping me to go in.
Yes, glad to have you here too. We are seeing your screen, Nicole. It's just not your slides quite yet.
Yes, I know.
Okay.
Yeah, there. So that's it.
Perfect. Thank you.
Okay, super. So, yeah, hello everyone. So my name is Nicole Pinel. I'm from the DLR in Germany, and together with my colleague Uta Heiden, We will present we will give you some overviews of current and future hyperspectral space-borne systems. And we would also like to talk about possible synergies with other multispectral instruments. So we would like to, with this talk, we would first give an overview, and later on we would like to raise a bit of a discussion about what is required to get synergies between different instruments and exploit them to the most optimal way. So, so first of all, I just give some overview of some hyperspectral or some imaging spectroscopy missions which are currently in space. So what you see here at the moment are all the green arrows are those ones which are currently running, and those blue ones are those ones which will be launched within the next 5 to 10 years. I don't want to go too much into detail of all of them, but I think it is quite obvious, like since, let's say, 2015, for example, there is quite an increase in hyperspectral missions which have been launched. I just want to pick out a few of them. So, for example, the CRISP prober. So to the best of my knowledge, it's still up and running. So it's kind of the dinosaur of this. And I think the lifetime of this mission has already exceeded many, many years. I should also maybe say that this slide here is, there is no claim of completeness or no claim of correctness. So this is just a personal collection of myself and of mine, Uta's, best of our knowledge. So if there is any mistakes or if you can add anything, so please contact me anytime. So I just constantly update these slides as good as I can. Yeah, so what we also see here, there's a couple of like on the ISS, there is quite a few instruments, hyperspectral instruments currently running. So for example, the DESIS instrument, which is also the Uta is, for example, the science coordinator of this mission, and there is also the Hisui, the Japanese also mission on that on the ISS. And most important, probably at the moment, which is running, is the Prisma instrument from ASI in Italy. So Prisma, yeah, is very similar also to NMAP, for example, a very similar instrument which will be launched in about 2 weeks' time. But all of them which are currently running at the moment, we can say, maybe except of the HypeSO, the Norwegian one, which is a very CubeSat satellite, all of them are, let's say, only semi-operational, mostly focused on scientific use, and they all, except of the HypeSO maybe, are all very much focused on land applications. So there is really none which is specifically designed also for aquatic applications. And like for the future satellites, which are hopefully coming within the next within the next years, the next one which will be launched, as I mentioned already, is NMAP in about 2 weeks' time on 1st of April. So we are very excited about that. But I think most interesting are probably then also those bigger missions which are probably coming in 2028, like the big missions like CHIME and SPG, which are more and more becoming or getting an operational mode. What else is there to say? So yeah, so that's pretty much the overview of those satellites. If we look a bit more into detail into the spatial characteristics, we can also see, as in particular those ones, the green, those running missions. It seems to be quite a standard specification of those ones with a 30 meter, so like 20 to 30 meter pixel resolution and about a 20 to 30 kilometer swath. It seems that this is currently the specification or the configuration which is technically the most feasible one. And with those ones which are coming, with those future satellites, I mean, there is well, some of the specifications were not available here, but well, as you can see, that this is kind of the range of the spatial resolution which most of those sensors have at the moment. And if we look at those spectral characteristics, we can also see that, well, most of the sensors have a Vernier and a SWIR spectral range, all between like 100 and 200, 250 bands. So they are all not so different. Some of them also include the thermal TIR spectral range, which also extends the amount of applications. Yeah, so that's basically the overview of those hyperspectral satellites. And what we can also read from this is that kind of it seems that there is a trend that there is more and more hyperspectral sensors being launched in the near future, and but they in particular, if you look at those aquatic applications, and I also know from the SEO's feasibility study, but also from some Earth Explorer proposals, I know how difficult it is to incorporate all the requirements, let's say, from the aquatic community into one single instrument, because in particularly all the complex requirements we have for the aquatic environments, it often is very difficult to put that all into one instrument, like having a very high spectral information, having a very, very high spatial information for those shallow water areas, for example, having a very high temporal resolution. If you look at the very turbid, fast-moving waters, and on the top of that, most important, having a very, very high SNR, with currently, as I can see, none of all those sensors have at the moment, which aquatic requirements for very dark waters would require. So there is still a big gap, and the next question would be like, how can we maybe improve or accommodate that with maybe having some synergistic harmonization with maybe other instruments. So if we look at that slide, for example, that also highlights again, so where the hyperspectral instruments are in comparison to maybe some multispectral and as Arnold calls them, workhorses, such as Sentinel or Landsat type sensors. So up here we can see the ANMAP, which is only representative for any kind of hyperspectral instrument at the moment. So it's up in the upper corner with the red brackets, whereas those ones with the green brackets are basically those sensors which have a very, very high spatial resolution, but only a very medium to low spectral resolution. And those blue brackets are those ones which have a low spatial resolution and also a rather low spectral resolution. But the question is really like, how can we harmonize or we can also call it cherry picking, like that we use like the very high spectral information from those imaging spectrometer instruments, but somehow use also the higher temporal resolution, for example, from those long global operational workhorses such as Landsat or Sentinel or other type of sensors. And with this question, I would leave it here at the moment. I would like to hand it over now to Uta Heiden, because she will discuss a bit more about the synergies, about the different missions and the different options, and will also raise some more brainstorming questions, which we can later on discuss, hopefully then in a discussion of this session. So that would be fantastic. And I would, with this next slide, I would like to hand it over to Uta Heiden.
Yeah, hello everyone. Thank you very much, Nicole. I'm Uta Heiden, also working at DLR together with Nicole, and very much involved in these hyperspectral missions, especially in DESIS. Well, Nicole already talked about all these different instruments and how we can maybe use it in a synergistic way. And I would like to start with let's say an example because I think it's first of all also about the question which data is available for your specific site if you are coming from the application point of view. So maybe you're aware of the ESA's Copernicus hyperspectral mission CHIME, which is very much already in preparation. And one of the tasks is to develop algorithms for the different applications. We have this main applications of food and agriculture, and the second is also mineral exploitation. And for these, there are a couple of sites across Europe where we have responsibilities, so-called PIs, and they are responsible for getting data for those specific sites from different instruments. And in this way, THESIS, so that is the hyperspectral instrument on ISS, supports the CHIME campaign. We are acquiring data for those sites as far as we can see it with THESIS on the ISS orbit. So, and in the next slide, could you please? Yeah. So I would like to give you an overview about the data availability that we have from 2021. So actually we started to collect data in 2020, continued in 2021, and we'll also continue that in 2022, so this year. And you can see here a selection of sites on the left side. And then on the colored rectangles, you can see which kind of instrument data we already have for those sites. So in blue, we have field campaigns. So there were quite extensive field campaigns in 2021. In this reddish color, AVERIX, the airborne instrument has flown over. Then the PRISMA instrument, the hyperspectral instrument of ASI, has acquired data, and also THESIS has acquired data. And as you can see, it's actually quite nice for certain sites that you have a coincidence of acquisitions for all these instruments and also field data, but you also have across the whole, let's say, season, recurring observations from PRISMA and from THESIS. So, and this is actually something very nice, but the question is actually also, how do we can deal with the different data types? So there are already just 3 sensors, but I can tell you that this is not very easy to retrieve the same, let's say, application product from these different sensor types, because each of the sensor type has different characteristics: spatial, spectral, temporal, radiometric, and so on. So that leads us really to the question: how do we deal with those different characteristics of these instruments? Maybe Nicole, we go to the next slides, because actually what we have discussed a little bit about how we can place those questions about synergies, and we are speaking here about synergies between hyperspectral and multispectral sensors, but also among hyperspectral sensors. That's also something like which is very difficult. And I had also a couple of discussions with others because the question is, why actually do we want to have these synergies? So, because I think this is the first question to ask ourselves: for which purpose do we need the synergies? And maybe this is actually also driving the way towards a synergistic use of those sensors. So we have collected here a couple of discussion points. So in our view, okay, we are DLR, we are space institute. We at the first hand, we would like to support future mission developments. In that case, speaking from THESIS, it was NMAP, but also as I showed already, CHIME, and I think we had already also meetings to support AquaWatch Australia, which is a mission, a planned mission, as far as I know. So this is something I think very important. The second issue where a common use of different sensors. Let's think about all these nice sensors on ISS. We have a CO2 mission, Ocho 3, we have 2 hyperspectral missions, and maybe the third will be launched soon, the EMIT mission. We have a LiDAR mission on the ISS, all on the same platform. So it's really a quite nice collection of different instruments on one platform. And the question is still, how do we would like to use it commonly? Because there are not, to my knowledge, not really much groups that are targeting to the synergistic use. And of course, what the most obvious advantage is to increase spatial, temporal, and also the spectral coverage of data, Earth observation data, that we can use for our applications. And then this is a little bit also in the direction of the example that we have from ISS, advanced product development. Maybe we need, or I'm quite sure, I know it from Forest, for instance, that it's kind of a standard to combine LiDAR data for the biomass estimates and hyperspectral data for species species classification, and so on, to come to really data products that tells us about Earth system processes that we would like to see. So in our view, I think we think that with the synergistic use of all these sensors, you get a wider acceptance of instrument, and also if you're speaking about imaging spectroscopy of those data sets for Earth applications. And also and I know that the aquatic community has discussed it quite much about a constellation mission, or a combination of different sensor types that you need for your specific purpose. So the question is now, how do we go there? And yeah, that's really difficult, I would say. And I had discussions with colleagues from NASA, Kurt Tomey, with Martin Bachmann, which is very much in Carlyle and quality products, and Sin Yong from Australia also, about what is actually harmonization of sensor system. What does it mean? Or cross-calibration. We all talk about we need cross-calibrated data, we need data harmonization, and so on. So, but what does it mean actually? And even among the expert, that's not a term that is clarified yet. So we were actually, unfortunately, it was not happening due to Corona, but we were planning actually a whole workshop for this topic. And I think this would be really necessary to come up with concept that people are or agency are really started to look at. And then there's another, of course, there are other ways, and Arnold already mentioned that very much. And this is a really important step, these harmonization of data formats and so on, with the Card for Land initiative, the ARD certificate from Sears. That the next point, common Calval strategies and sites. Well, that's always what first comes into your mind if you're speaking about synergies. It's one aspect, I would say, but not the only one. And I mean, developments are going already in this direction. So with CEO's RadCalNet, for instance, and I also know that Australia is quite active in that part about calibration strategies. Then data harmonization tools. I heard that also for there's this is it a project or initiative? I'm not quite sure, but there's a initiative called Send to Like to adapt, so to harmonize Sentinel-2 to Lancet-8. And I know also from other calls from ESA that this is something they would like to extend also to other missions like the hyperspectral mission. So this is coming really very important, but this is a point where you clearly say, okay, my master instrument is this one, and I adapt all the other data towards this instrument. So this is also a discussion that everyone needs to do. And that's also what
Sorry,
Arnold
because of
says.
the time.
Oh, I'm sorry. Yeah. Just this quick point here. They need a clear demand from the community, and Arnold has mentioned that already, that they need harmonization initiatives and projects, and that one of the floor could be a GEO or CEOs. So I have other slides here, but maybe I think we raised already a lot of points. So this is just an example of how we plan the synergies between DSIS and MMAP. And maybe the next slide. This is listing the potential collaboration between hyperspectral missions and multispectral workhorses like the Sentinels. But I think I made the point clear that first of all, we really need to answer the really demanding questions that I raised in the first slide. I hope that that's okay. Sorry for extending the time very much.
No, thanks a lot. I'm very sorry to interrupt, but I think we are running a little bit out of time.
Yeah.
So if you have any questions for Ute and Nicole, please write them in the Q&A point, and then I would like to invite the third and the last presenter. Yes. Thank you. Can you introduce yourself as well?
Hello on my side. I think I should, this is Apostolis Zimas. Try to retrieve control of the share screen button at the moment. Right. I don't know if the organizer should somehow switch or take the control of the presentation and share it to me on my side.
Nicole, could you stop sharing your screen? Thank you.
Well, in the meantime, until I manage to upload the presentation, it's Apostolis Zimas, Managing Director at Envis, coordinating the Moment Prime Water Research and Innovation Project funded by the European Commission. I still can see how I can use my share button, my share screen button.
Nicole?
I'm sorry, I don't know how to unshare my screen.
Right.
I'm still presenting, I know, but
Right.
how do,
Yeah. Look, maybe minimize everything on your screen. Click the Air Meet button at the bottom. Do you see that on your bottom toolbar? There's one button that's highlighted.
no, I can't see it.
It's a green circle.
No. No. I don't know how to unshare it.
Do you see a big X in the middle of your screen?
No, there is only the screen, and there is no. No. How do I do that? No, I don't know. Maybe I leave the session. I don't know.
Yes. Okay. That's an option.
Okay.
Right. Okay. I'll start. Okay. Seems that
Can you try it again now?
Yeah, he's trying to share.
yeah, try to do that, but it doesn't seem to work on my side now. That's really unfortunate. I'm not sure if. Right. Okay.
There it goes.
Thank you.
I hope you'll can see my screen.
We do.
So going skipping introductions. Well, Prime Water has a strong focus on working with Earth observations and producing towards production of new improved water quality products. In particular, looking at the hyperspectral sensors like Prisma. But for today's discussion, the focus will be around how we can further exploit, let's say, the potential of Earth observations. And within Prime Water, this is sought on how Earth observations can generate foresight for the water sector. Well, that is from not only having observations to tell us about what's happening now, but shifting from that state to how observations can be used to build credible cause and effect analysis, and even further, let's say, downstream to actually use, integrate forecasting models, predictive models, together with planning and analysis tools, which are sector specific, in order to generate downstream services tailored for the water sector. Prime Water has also a clear focus on local scale applications intended for operational use, as opposed in a way to global analysis applications where Earth observations have so far and can demonstrate so far a strong record of good, let's say, performance skills and benefits. So talking about hydroecological forecasting, a multimodal chain is needed, starting from weather forecasts, hydrological forecasting, trying to predict river discharges, water temperature or fluxes of sediment and nutrients. And of course, when it comes to the lake level, hydrodynamic and water quality modeling components are in need. In all those levels, at Prime Water, we have been testing different Earth observation derived products with data simulation methods, trying to investigate their impact to the overall performance of those components. Evapotranspiration products, functional snow cover or snow water equivalent were used in hydrological forecasting models. And when it comes to the lake, let's say environment, Sentinel-2 and Landsat 7.8 temperature and chlorophyll A products were mostly used to run some experiments. I need to say here that those water quality products mostly was produced using EOMAP's MIP algorithms. Well, these are the areas, the showcases where we have concentrated effort within Prime Water, set up test beds and run several experiments in a collaborative way. And well, I'll try to be very, very quick on that, and mostly to present, well, a quick overview of the examples where within this modeling chain, our team has tested the proof of concept of using Earth observations in different modeling domains, starting from the catchment area. Here, the Swedish Hydrological and Meteorological Institute has actually run a very comprehensive assessment of how Earth observation data can improve the performance of seasonal streamflow forecasting. Well, this work is documented and it's available. The full analysis is available on the literature papers shown on the slide. But it's good to actually highlight one or two areas particularly interesting to hydrologists when obviously performance varies with the parameters simulated, the variables simulated, and the period of testing. Snow water equivalent seems to be quite interesting, having the longest persistence, for example, making it very, very, when assimilated, making it very useful during spring floods. And that was a very nice outcome of this work performed by the Swedish team. Moving from the catchment area to the lake hydrodynamics and water quality, here experiments mostly have been conducted with using a coupled 3D hydrodynamic and water quality model. Ensemble Kalman filter data simulation methods have been automated to enable those investigations. Well, this is an ongoing work. However, there are promising results out of these investigations become available towards the impact of temperature and chlorophyll, for example, simulation in models. They seem to have a good improvement in the performance, although this performance seems to dissipate after a few days, after 4 days. Well, that's an interesting preliminary, let's say, result as well. I mean, talking about the lake level and the lake environment, Prime Water also went beyond physics-based modeling and tried to implement data-driven models and Earth observations. So two families, large families, have been investigated. Regression forest and Gaussian process algorithms were investigated in this work. Using Earth observation derived water quality parameters, mostly chlorophyll, produced by Sentinel-2 and Landsat, together with meteorological reanalysis data and hydrological reanalysis data. Models were trained with those algorithms. Machine learning algorithms were trained with those data. And as I said, this work aiming again in proving the concept of how those models can be used as predictive tools together with Earth observations. Again, there are results showing that predictions from those models can indicate a good, let's say, cause and effect relationship between variables and explaining how phytoplankton dynamics work. Again, performance varies along different methods used, different algorithms, and this is also very important. But in any case, they seem to have promising performance as a means of using Earth observations to generate predictive models for water quality. Well, finally, another example where we, our team within Prime Water put effort was to use machine learning algorithms to identify systematic errors that actually are generated from process-based models as a complementary, let's say, error correcting mechanism for physics-based modeling, trying to investigate how this concept can be used as a hybrid, let's say, approach in forecasting systems. Again, here is a work in progress with a lot of good potential that we try to investigate within Prime Water. So that was just a few examples of how, let's say, Earth observations can generate further forecast adding value together with modeling tools. But beyond these, let's say, concepts, it was important for us to find a way to communicate those in an efficient way towards end users. So the platform has been developed, actually could support and streamline the results of those concepts that are tested in Prime Water. So the Fresh Water Quality Intelligence Suite is an operational, is a tool, is a platform where users can actually see how those concepts can work operationally and retrieve data, monitoring data that actually are derived from Earth observations, have access to water forecasts, hydroecological forecasts, just like a service. But even further to that, to demonstrate how downstream services like early warning systems can be supported by forecasting tools. Move so fast here. And shift, for example, from early warning systems that are based from nowcast information, from monitoring systems, towards early warning systems that are based on forecasting, credible forecasting systems. Either those can work on a deterministic or probabilistic way. And to make a connection with what we have discussed in the beginning as an increasing adding value, let's say, opportunity for Earth observation was to investigate even downstream solutions that can allow proactive management of hydroecological risks tailored to the specific, let's say, needs of particular end users. So since time is running out, I mean, this is the last slide, mostly to intrigue and stimulate some discussion later on. Well, there's a lot of good opportunities in science, in earth sciences, a lot of let's say, ways to achieve the end result that becomes sometimes really confusing, particularly to an end user. So the point, credibility of the science is very important. And I think a connection here with what Arnold has presented earlier as a framework to ensure this credibility. I'm sure that can find room in all those different levels of a multimodal approach. But even that, even if science is, let's say, operate and contribute has a terrific, let's say, contribution, terrific outcomes, still there is significant road, space to cover when it comes to user expectations. And I think that might be a strong, let's say, area for discussion, perhaps days. Well, that's from my side. Just big thanks to the Prime Border team. I think I'll stop here and pass the floor back to Gada.
Yeah, thanks
Thank
a
you
lot
for
for your presentation. This is tying up what we have in the other two, and I would very much thank all of the speakers for their presentations, and I would hand in to Maribeth the sharing. Thank you.
Great. Thank you very much, everybody. It was a very successful session. Not to be rude, but we're going to bop on over to session 5, which is starting right now. Thanks again to all our speakers, and please join us on the Miro board for further discussion. Bye, everybody.